Hello, in this video, I'm going to try and solve the Leetcode question number 160, which is called intersection of two linked lists. So the description of the problem is, given the heads of two singly linked lists, head A and head B, return the node at which the two lists intersect. If the two linked lists have no intersection at all, return null. For example, the following two linked lists begin to intersect at node C1. This is the graph. The test cases make sure there are no cycles anywhere in the structure. The linked list must retain their original structure after the function returns. Okay, here are test cases. Okay, so the parameters are head A, head B, and the output should be the one of the nodes, so the one where these two lists intersect. So the idea I have for this is to traverse through both of these lists. So first go through list A, and when it reaches the end, switch to list B, and this way we should be able to find the point of intersection. So as usual with linked lists, it's a good idea to create pointers. So I'm going to do that. Pointer A will be our reference to head A. Pointer B will be the reference to head B. Actually, let's take a bit of a shorter example. So we need a while loop. And at that moment, I'm not sure what the breaking condition should be. So for now, let's say that if PA exists, meaning when we reach the end of this list, we should exit the while loop, because we should remember that in this node, the next property should be none. So what do we need to do here? We need to compare PA and PB. So if PA, here I would suggest doing the identity check instead of comparing the values, because it could happen that if we have value 1, PA and PB will have the same value, but they will be actually different objects. So this is why we need to check for the identity. So if PA is not PB, we should move PA to the next node. So PA will be reassigned to PA next. And the same for PB. If PB is not PA, PB will be reassigned to PB next. Okay, so here we can see that actually we are doing the same check twice. So it would be a good idea to put this check in the while loop. So it does make sense. We will iterate as long as PA is not PB. So if PA is not none, we move to the next value, or the next node, should I say. And if PB, we move PB to the next node. Okay. So what happens if we have reached the end of the linked list? Let's say that we have reached PA 4, and now PA is equal to none. So we need an else statement, which should say that now PA should start traversing the B list. So PA will be reassigned to head B. And the same for the second part, else PB should be reassigned to head A. And when we exit the while loop, we should return PA. Actually, it doesn't matter. It could be also PB since we exit once they are the same. So let's see on this example how it works. I'm going to make comments. To see what's actually happening with the variables. So let's start with PA being node 1 and PB being node 3. So this condition is met. PA is not PB. PA is not none. So we can move on to PA being 9. This line is not executed. PB from 3 moves on to 2. I'll comment it out. And this is our intersection. Okay, we have reached the end of this while iteration. In the next iteration, PA becomes 1, PB is not 2 anymore, it becomes a 4. End of iteration. Next iteration, PA becomes 2, not executed, PB becomes none. Next iteration, PA is not PB, PA becomes 4, not executed, PB is none, PB is none, so it becomes head A. Which is 1. Okay, moving on. PA is not PB. PA now becomes none. This is not executed. PB from 1 becomes 9. And now PA is none. So we execute this line and PA will become 3, which is the head of B. I'll delete this. PB becomes 1. Now PA is not none. It's equal to 3. So PA becomes a 2. Had a PB was 1 and now it becomes 2. So in that moment PA is PB, we exit the while loop and return PA. Let's see if this works. Yes, all the test cases have passed. We could submit this solution, but let's also see another edge case because I'm curious how to visualize this third example, the case where there is no intersection at all. So let's do the same kind of exercise. So in this case, let's start with PA moving from 2 to 6, PB moving from 1 to 5, then PA moving from 6 to 4, PB moving from 5 to none, PA moving from 4 to none, PB changing from none to head A, which is 2, PA is becoming 1, so here we can see that if we iterate maybe 2 or 3 more times, both of them will reach none. So once PA is none, PB is also none, we return PA, which is none, and this is exactly what we were asked to do. So this is my solution. Let me know if you have any ideas on how to improve it, and thanks for watching.